All right, all right. Today we're going to be talking about modeling real-world problems with one-step equations. And these are from the practice problems found on Edgenuity. Again, modeling real-world problems with one-step equations. So sometimes solving the equations can be relatively easy. There's an algorithm, and an algorithm is a set of rules that you must follow to solve one-step equations. You isolate the variable, get the constants on the other side, isolate, do the inverse, and solve. But sometimes translating from a word problem to the equation, or from an equation to a word problem, can be a little difficult. So we're going to go over that today, and hopefully we can make a little sense of this. Okay, so let's read the first problem. Hava spent $11.61 downloading songs, and each song cost $1.29. 4 students wrote and solved equations to find S, the number of songs that she downloaded. Which student wrote and solved the equation correctly? Now, I've taken away the answer choices because I didn't want to just give you the answer. So we are going to work through this together. Okay. So first we're going to do 11.61. That's the total that I spent. And I know that each song is $1.29. I can put the dollar symbol in front of them. No, I'm not going to. So this is the total amount I spent, and I know each song is $1.29. Now the variable that they gave you is S, and that's a bad variable. But every time I write an S, it usually kind of looks like a 5. So I'm just going to go ahead and change that to an X. And whether you use an X or an S, doesn't matter, you're still going to get the same answer. So ultimately, what you're asking in this problem is, you spent $11.61. Each song is $1.29. So how many songs did you download? Okay. So to do that, so we translated our word problem into this. That's an arrow, an ugly looking arrow. Okay. Now, when we get to a one-step equation, the first thing we need to do is we have our variable over here. We need to isolate that variable. So what am I doing to the x? If I have a number next to the variable, that means I'm multiplying the x by $1.29. What is the inverse? Kind of like the opposite. What's the opposite or the inverse of multiplying by $1.29? That's right. I'm going to do this in blue. Is dividing by $1.29. Because 129 divided by 129 is 1, and 1 times x is x. So we've gotten the x alone. Again, just like in the a fraction, whatever we do to the numerator, we do to the denominator. Whatever we do in an equation, whatever we do to the right side, we do to the left side. And so I'm going to cheat, do this on the calculator. 1161 divided by $1.29 is 9. And so I can plug that back in. If I plugged in 9 times $1.29, I would get $11.61. So this is my answer. Okay. Now, when you're doing a problem like this, if you want to do it by hand, that's great because, again, dividing with decimals, you will be going over that in class, in my class. But please feel free to check your work with a calculator. You get to use a nice calculator for the STAR test and most of the work that we do in class after I realize that you're really good with operations with rational numbers. But always check your work with the calculator. All right, next one. Millie needs a total of 7.8 feet of ribbon for a school project. She needs 0.7 or 7/10 more feet of ribbon. How much ribbon in feet did Millie already have? Write and solve an equation to find the answer. Okay, so I know she has some ribbon. I know she needs this much more feet, but I know in total this is what she needs. Okay, so again, I know she already has some ribbon starting off. I know that she needs a little more ribbon to get to her total of 7.8. So again, we went from a word problem to an equation. So we have some ribbon. We need 7.8. we need this much more, so how much did I start off with? Now, once we're at the equation part, we can solve it. So again, in a one-step equation, we need to isolate any kind of an equation. We need to isolate the variable, so you're going to look at what you're doing to the x. We need to get the x on the left-hand side. We need to get the constant. The constants are numbers by themselves. There's no variable with them. You get the constant on the right side. So I'm adding 7/10. So what is the inverse of adding 7/10? That's right, subtracting 7/10, because that cancels out. If I had 70 cents and I took 70 cents away, I would have 0 cents. So now I have the variable on the left side. Now, but in an equation, we have to keep it balanced. Whatever you do to the left side, you have to do to the right side. So 7 8/10 minus 7/10 is 7.1. So 7.1, 7 1/10 feet. Always label your numbers. So that would be our answer. So how do we do this? Millie needs a total of 7.8 feet of ribbon. So that's how much she needs. She started off with some, but I know she needs a little more. So we set it up, and then we solve it algebraically, isolate the variable, get that constant, 7/10. On the right side, by doing the inverse, the opposite of adding 7/10 is subtracting 7/10. Whatever you do to the left side, you do the right side. We get 7.1 or 7 1/10 feet, and that is our answer. All right, next. Dan was asked to write an equation and solve this problem. Sorry, it's so high up there. Dan was asked to write an equation and solve this problem. Okay. Shonda has some small spoons and 40 large spoons. If she has 68 spoons total, how many small spoons does Shonda have? Oh, that's a Liam, not a Dan, sorry. Liam's work is shown below. All right. So you see the work here in the box, on the table. In which step, if any, did Liam first make a mistake in her work? Okay. So let's look at this. All right. So we translated it, and we said Shonda has some small spoons. I don't know how many small spoons, so they wrote the variable s, and again, I'm just going to turn it to an x. And I know she does have large spoons, when she had 40 of them. If she has this form of is, and is means equals in a math equation, 68 total spoons. So, did she make any mistakes? So the first thing we need to do, we have the variable on the left-hand side, my x, or s, whatever you want to do, and then I'm adding 40. So the inverse of adding 40, that's right, would be subtracting 40. Now I'm doing it vertically. They did it horizontally, but that's, who cares, same thing. This cancels out. Of course, whatever I do to the left side, I do to the right side. And that leaves me with x is 28. If I plug 28 back into the original equation, 28 plus 40 does equal 68. So, did she make any mistake? No, she didn't. She solved it. She set it up perfectly, solved it, following the proper steps. So, good job, Leon. All right, last one. Zoe placed colored blocks on a scale in science class. So each block weighs 8/10 ounces. The total weight of all the colored blocks was 12.8 ounces. How many blocks did Zoe place on the scale? Write and solve an equation to find the answer. So, what do we know? We know we have blocks. How many blocks do we have? I don't know. But I know the blocks weigh 8/10 ounces. 0.8. And I do know I know my total is 12.8. So this one is an easy one-step equation. I have a number, a different color, number next to a variable. That means I'm multiplying by 8/10. And what is the inverse of multiplying by 8/10? That's right, dividing by 8/10. Because 8/10 divided by 8/10 is 1, and 1 times x is x. So we got the variable alone. And of course, whatever you do to the left side, you want to do to the right side. And so, let's go ahead and write this out. Divided by 8/10. Now, as you guys know, there are parts of division. We have our dividend, we have our divisor, and on top we'll have our quotient. Now, just a friendly reminder, we cannot have a decimal, our divisor, so we have to get rid of that. How do we get rid of that one loopy thing? And how do we do the loopy thing? We multiply by 10, because 8/10 times 10 is 8. But, you know, in an equation, whatever we do to the left side, we do the right, or vice versa. In a decimal division problem, whatever we do to outside of the box, we do to inside of the box. So if I multiplied 8/10 by 10, I'm going to multiply 12.8 by 10. And so this is going to actually become 128 divided by 8. Either way, I'm going to get the same answer. If I can plug this right here into the calculator, 12.8 divided by 0.8, and it's going to give me the same answer as if I followed the proper steps and divided it. 8 will go into 1, will go into 12, and we get 1 times 8 is 8, 12 minus 8 is 4, bring down the 8, and we get 48, and kind of skipping some steps because I'm running out of room, and 8 will go into 48 6 times, and 48, and I'm done. So my answer is 16. So Zoe placed colored blocks on a scale in science class. Each block weighed 8/10 ounces. The total weight of all the colored blocks was 12.8 ounces. How many blocks did Zoe place on the scale? Well, it's just what can I multiply 8/10 by to get to 12.8, or 12 and 8/10? And the answer was 16 because we solved it algebraically. So again, these are the practice problems. I'm going to go back. On modeling real-world problems with one-step equations, which can be difficult at first, pay attention to the way it's worded, because you're just translating. It's like translating from English to another language, but this language we're using is math. And again, math is a language in which you can communicate things. So pay attention to the way it's worded. Set up the equation. Now, Edgenuity is not that difficult because, again, you do have multiple choice to pick from normally. So pay attention to the way it's worded, translate it, and then solve it. Solving one-step equations. I have other videos on solving equations, so if this doesn't help and you just need help with solving equations, you can go to my videos. So hopefully this has been helpful, and if you need anything else or have any questions, you can email me at jhewlett@leisd.ws. Thanks, and have a great day.